Let's wait for others to join and then we'll start the class. Just let's wait 3 or 4 minutes. Let's.
Okay, sir.
Okay, so we'll start the class now, all right? In previous class, I have given some homeworks. How many of you have done it? I've asked you to find the derivative of cosecant of x, secant of x, and cotangent function. How many of you have done that? And can you please tell me the answer? Like, if, f of x is given, your cosecant of x. What will be the derivative of this function? We have studied trigonometric functions, right? We have seen the derivative of sine, cos, and tan, these functions. But what are the derivatives of these cosecant of x? What is the derivative of cosecant of x? Anyone please tell me? Can you please repeat one more time? Shreya, it was you, right? Okay, anybody else? Anyone? No one? Okay. So the derivative of this function is minus cosecant of x into cot x, right? Okay. So if the given, so what will be the derivative? D upon dx of cot x. Anyone? Minus cosecant square x. All right. Derivative of which one is left? Secant of x. Yes. Anyone please tell me? secant of x into tan x. Yeah. So this is the derivative. I have asked you to do these problems. I don't know how many of you have tried, but it's okay. Okay, see, we have studied about derivative as a limit of function. We have studied about the geometrical meaning of derivative. So in a 2D plane, in xy plane, the meaning of derivative, where if there is a given function, suppose this is a function given f of x, okay? So derivative at a particular point, at this point, okay, we have understood let's say this point is a. So the derivative of this function at this point, it means slope at this point, right? That's what we have studied, no? Okay, so whatever angle it is making with this x-axis, that's the meaning. So this red curve represent f dash, sorry, derivative f dash, okay, f dash at a, okay, f dash at a, this point, it does not represent derivative at all points, it only represent derivative at this particular point, okay? So theta, so tan theta, you can write tan theta is equal to f dash of a, okay? That's the meaning of, this is a geometrical interpretation in a 2D plane of derivative, okay, of a simple explicit function. Now there are two types of functions again, explicit and implicit function. See, explicit function is simply in which you can arrange the equation in terms of y. That means directly you can write y in terms of y as a function of x. Okay, when the function is mixed, like you cannot write y directly as a function of x. Okay, that type of functions are called implicit function. All right. So implicit function derivative is not there in your syllabus. I'm not going to cover it. If it is there, let me know. I'll cover it. Okay. But for now, I'll give you some of the. I'll keep writing some of the derivatives of standard functions, which we are going to use in order to find derivative of other functions. Okay. So let's write down differentiation. That is the geometrical interpretation, by the way. Okay, geometrical meaning. We have also studied that in some class. Okay, let's check. Here we had the geometrical interpretation. Okay, limit derivative as limit of sum. All right. So we have done in the first class of derivative itself. All right. So differentiation or differential coefficient. See, differentiation is also called differential coefficient. Okay, differential coefficient of standard function. Let's say functions, multiple functions we are writing. So let's write down the first one, that derivative of any constant is what? 0. Okay, this you can also write. That means you differentiate it with respect to any function. Let's say x, that is a constant value. The differentiation is always 0. You if you want, you can also write the d upon derivative with respect to any function as well. Function of x, function of y, doesn't matter, of a constant is always 0. Okay, so differentiation of a constant function is 0, because you geometrically also we can understand this part, right? See, suppose there is a constant function y x. How you will draw a constant function? See, this is the constant function, right? Now if you find out derivative at any point, at all points, what is this going to be? This is going to be a horizontal line. This is going to be a horizontal. See, your derivative geometrically, what does it mean? It means the tangent. So at all point, tangent it the line itself. Sorry, tangent is the line itself, right? So this is your constant function. Y is equal to some constant, let's say a. Okay. So now you see this is parallel to x-axis. That means the angle that it will make, what angle it will make with the x-axis? It makes angle 0. Theta is equal to 0 degree or 180 degree. What you can say both. So tan theta is equal to what? 0. That's why the slope is 0 here. Understood? All functions you can understand geometrically. It's very easy. Okay, so second one, derivative d now in shortcut I'll write d upon dx of x to the power of n. What we have learned, n x to the power of n minus 1, where n is some constant. Okay, n is some constant value, or it can be functions as well. We will see that in implicit function, but for a straightforward answer or a simple answer, let's understand it like this. Okay, once we solve a lot of problems in derivatives, we will get to know that n can be function of x as well. Like you can find the derivative of f to the power of g, and both are the function of x. Okay, so those type of problems. Yeah, guys, I'm really sorry I have to attend this. I'm really sorry. Just a minute. Really sorry, guys. Now derivative, derivative of function modulus of x. Okay, so function modulus of x, what will be its derivative? It will be x upon modulus of x. Okay, I'm just directly writing because it depends. And x, how modulus of x, how do you define modulus of x? Its value is x if x is greater than or equal to 0. It is minus x if x is lesser than 0. All right, so please write it down. All right, the fourth one. Okay, so we have, see, this is the only function, e to the power of x. Okay, exponential function whose derivative is itself. You will also learn its integral is antiderivative is also itself. Okay, this is the only function. Remember that. Now let's say the fifth function, d upon dx, the derivative of function. Which function? Let's say a to the power of x. Can you find out the derivative of a to the power of x? Can you find out the derivative of a to the power of x? Yes, try it. Yes, what is it? Anyone? You have to use the property of logarithm. Use it. Yes, can anyone tell me the answer?
Sir, x,
Yes.
x into a to the power of x minus 1, sir.
Sorry?
X into a to the power of x minus 1, sir.
X into a to the power of
X minus 1.
x minus 1. No.
No, sir. No, sir. X to the power 1. No. A to the power x minus 1, sir. X into a to the power x minus 1.
X into a to the power of
X minus 1.
x minus 1. Okay, no,
Yes,
this
sir.
is also incorrect. See, this is logarithmic limit. Okay. Sorry, derivative. How you will find it out? Can anyone tell me the answer? See, the given function, let's write down y is equal to a to the power of x, right? Here you have to understand a is not the variable, a is the constant. Okay, a is a constant. So you cannot just write like this. You are using this formula. You cannot use it because here n is constant and x is the dependent variable. Sorry, independent variable. Okay. Now here a is constant and x is independent variable, right? Now can you take natural log both side. Okay, so what we can write, you will write natural log a to the power of x. Natural log of y is equal to natural log, sorry, x into natural log of a. Now ln a, if a is a constant, that means this entire value is a constant. Now you see that y is a function of x, right? Now if you find the derivative of y, now you find the derivative with respect to x. Ln y is equal to d upon dx of x ln a. Okay, so what this will become? This will be 1 upon y ln okay ln dy upon dx, which is equal to have we done logarithmic limits? Okay, before I give you all the answers, have we done logarithmic limits? Sorry, derivatives. Now ln a is a constant, right? D upon dx of x. Okay, so you can write 1 upon y dy upon dx, which is equal to ln a is a constant and derivative of x dx upon dx will be 1. So you can write dy upon dx is equal to y times of ln a, right? Now ln a is a constant and what is y? A to the power of x. Okay, so this is the derivative of the function. Okay, I think we don't know the derivative of logarithmic function. So write down dy upon dx of ln x. Okay, so this is equal to 1 upon x. The derivative of logarithmic function is 1 upon x. So using this, you can find the derivative of a to the power of x. Have you studied about logarithmic functions? How the rules of how to operate logarithmic functions? Hmm? Algebra of logarithmic functions. Have you studied? In one class, I think I have mentioned few points, right? Huh? Hari? Or somebody reply, or at least. Okay, I'll just write down a to the power of x ln a. Okay, a is a constant here. Constant to the power of x. So that's how you are going to find the derivative. Number 7. Logarithmic function. See, this is ln x. Okay, ln x. One more thing about logarithmic function. Ln x can also be written as log ex. Okay, the base is e here. When you just simply write log x, that means the meaning is base is 10. Okay, that's the difference. The value of e is how much? 2.7 something something something, isn't it? So ln x is equal to log ex. So either it is written log ex or ln x. That means it is natural logarithmic function. So hopefully you know the difference between ln x and see, this is ln x, and see some function f is ln x, some function g is log x. Okay, so if you see graphically how it look like, so both are different. Now with yellow one, I'll draw ln x. Okay, so this is your ln x, and with red one, I'll draw log x. Okay, this is log x. Understood? That's how it varies on xy plane. So this is x, this is y, this is ln x, this is log x. Or this is also equal to ln log ex. See, if you keep increasing the base, that means this base here, we write now log a b. So a is the base here. If you keep increasing the value of a, the graph will keep shifting like this. Okay, so like that. So here the base is 10, here base is e. All right, so that's how logarithmic function behaves. Now there are certain properties of logarithmic functions, like if y is equal to log a to the power of b. So you can write this as b log a, whatever the base is, it doesn't matter. So base here is 10, here also base will be 10. So if y is equal to, what else? Okay, log 10, some base can be anything. So you can also write this as 1 up. First you multiply it with b, that means you can write b log 10a. This you can also write as b 1 upon log, now base will become a log 10, like that also you can write. Okay, so it changed, the index is changing with base. All right, so you can also write like, see, these are the properties of log. Just go through the properties of logarithmic function and you'll find a lot. Okay, so that's why we so derivative of cos, sine, everything we know now, right? Now was the fundamental principle of derivative we have studied, right, in a graphic form. That means limit, sorry, not limit, why I keep saying limit. Derivative means derivative, left hand derivative of a function should be equal to right hand derivative of the function. And that's why we say that the derivative exists. The derivative exists. That means if this condition is not satisfied, the derivative will not exist. Understood? Yes or no? Anybody is having doubt here? Huh?
No, sir.
So see, left hand derivative and right hand derivative, I have checked that there is no such problem in NCERT book. So we are not going to study in that manner. All right. So I have told you this definition. Also, graphically understand the derivative, when derivative exists. See, suppose there is any sharp turn in a graph of any function, like, okay, or let's say something like this. See, something like that. So suppose this is a function of some graph. Now this function is derived. It can be. It is of this function exists at all points. The derivative of the function does not exist at this point, at this point, at this point. Okay, because there is a sharp turn in this function. Whenever you have a sharp edge, if there is any sharp edge on the graph, function is not derivable at that point. The derivative at these points does not exist. Understood? Like, if you find, suppose the given function is y is equal to modulus of x, right? If you can plot modulus of x, you know how to plot it, right? We have seen it a lot of times. Modulus of x. Okay. So modulus of x, you will simply draw like this, right? If this is your y, this is your x. So this is plus x, y is equal to plus x, y is equal to minus x, right? Now you see that this function can be, its derivative exists at all points. For all values of x, the derivative exists except at 0. So at 0, it has a sharp point, right? Sharp edge. So at 0, at x is equal to 0, the derivative of the function f of x is equal to modulus x does not exist. Understood? So graphically, this is how we can understand derivative. Okay, and not understand, this is how we will find whether the derivative of a function can be whether it exists or not. Okay, so the derivative of function does not. One more thing, see, I have told this multiple times, but for a reminder I'll write it again, that for a function to be derivable it must be continuous. Okay, so if the derivative exists, function must be continuous. Must be continuous at that point. Understood? Function must be continuous at that point. Let's say, okay, I'll just take some example which is in your 12th standard book, but I haven't checked whether it is in your 11th standard book or not. Okay, I think it is not, but let's see that. In NCERT, this example is there because derivative you have to again study in 12th standard, right? Okay, so this is y, this is x, and we are plotting y is equal to fractional part of x, f of x, which is equal to fractional part of x. This is how we represent fractional part. So this function is, this can be represented like that. That means only fractional part exists. Okay, this point is 1, this is 1, this is 2, this is 3, 4, 5. Now we see there is a discontinuity in the graph at every integer value because the name itself is fractional part function. Fractional part function. Okay. Understood? See, how fractional part is defined is x minus greatest integer of x. Okay, so at all x values, this is how a fractional part function is defined. Because you add the fraction part, you add the integer, you get x. You get x, right? This is how it is defined. So this is your fractional part function, and this is your greatest integer function. So if you add these two, you will get the value of x or whatever the function, it doesn't matter. Okay, so in this case only x we are finding out. This is how a greatest fractional part function is defined. Now you see there is a discontinuity at all integer value, right? At all integer value there is a discontinuity. That means the derivative exists from this point to this point, but not at 1, not at 2, not at all integer value. The function is not derivable at all integer value. The function is not derivable. Understood? So this is the graphical method how we can check the derivative of a function. If you know how to plot a graph, you can find out whether the function can be derived at that point or not. Okay. All right, so let's go to miscellaneous exercise and solve some of the problems based on this. All right, have you solved miscellaneous problems as well? Miscellaneous exercise problems have you solved? See, we have seen the product rule, we have seen the quotient rule, we have seen the chain rule as well, right? We have seen the chain rule, right? And implicit function, it's not there, so let's not go through implicit function and inverse function. When inverse trigonometric function you'll study in 12th standard, that time you'll be studying the derivative of that function. Okay, so product rule we have covered, we have covered the quotient rule. Okay, chain rule also we have covered, right? Don't we? Have we or not? See, chain rule is simply like y is a function of, suppose y is function of a function u, which is again, okay, let's write like this. Y is a function of another function u of x. Okay, so how do you find the derivative of this function y dash? y dash, how you'll find out, which you write dy upon dx. Okay. Now you see, y is a function of f. Y depend upon, see, y depend upon u of x, and f depend upon, and sorry, and u depend upon x. Okay. So this, the derivative you can find using, so you'll find the derivative of y, f with respect to x. So you'll write df upon du, sorry, with respect to u, and du upon dx. This is called chain rule. Okay. Understood? Like, let's take the example. Okay. Suppose the given function is y is equal to log of sine x. Okay. How you will find the derivative? So find dy upon dx, y dash. Okay. This will be equal to d upon dx. Sorry. So derivative of the function log of sine x with respect to x we have to find out, right? So how do we write this? You will write this as d upon d of log sine x with respect to sine x, okay, multiplied by derivative of sine x with respect to x. Okay. Now we know we have, that means here, now see, it is little confusing, right? How do we find the derivative of this function, any function, with respect to another function, right? So what you do, you just replace y with some z, sorry, sine x, let's say sine x is equal to z. Okay, here only. So what you can write, d of log z upon dz, you can write like this, right? This one multiplied by, here you just leave it as d sine x upon, now d sine x upon sine x, d sine x upon x is what? Dx. This is what? How much is this? Huh? How much is this? What is the derivative of sine x? What is the derivative of sine x? Cos x, right? Cos x. Now, what is the derivative of log z? Anyone? Derivative of log z with respect to z? So d, yes, 1 by? 1 by, yes, Shreya, you are correct. Say 1 by?
1 by z.
Yes, 1 by z. Very good. So 1 by z upon cos x. Sorry, 1 by z into cos x. This will be equal to, now what is z? Z we have assumed to be sine x, right? So you just write down cos x upon sine x, right? So what this will, cos x upon sine x is what? Cot x, isn't it? Yes or no? Yeah, so that will be your answer. This is called your chain rule of differentiation. Okay. All right. Let's go to miscellaneous problems. So we have done this problem as well, right? Sine x degrees upon x, limit x tends to 0, sine x degree upon x. How can anyone tell me the answer? We have done this problem. Yes, anyone, please tell me the answer.
It's not equal to 1.
It is not equal to 1. Okay, very good. But what is it equal to, Shreya? It is not equal to 1. Okay, good. I agree with you. Then what is it equal to? See, this is degree, right? First you convert degree into radian, because all the values are in radians, real number values. These are all real number values. And we know radian measurement of angle is real value measurement of angle. Real number value measurement of angle. So first find out that. Yes, tell me, Shreya. In x degrees, how many radians are there? Just write down that. X degrees, in x degree, how many radians? Huh? Somebody please tell me.
Degree measured by 180.
Sir. Yes, correct. Tell me.
Degree measured by 180.
So pi by 180 into x, right? That's what you're saying?
Yes.
Yeah, this you didn't said this. Okay, so limit x tends to 0, sine, now x degree, what you can write? Pi upon 1, pi by 180 into x, right? So what you can do, you can multiply in the denominator also pi by 180 to make these two same values into x. But since you have multiplied here, you have to multiply by 180 by pi here, right? So that it can you can cancel out these two and it will become the same equation. Yes. Okay, so again you can write limit x tends to 0. Now this value you can write pi by 180. This one we are writing. Okay, this one we are writing here into. Okay, so this is because this is a constant value, we can take it outside limit. Limit x tends to 0, sine pi by 180x upon pi by 180x. Now if you have problem, let's replace pi by 180 x to y. Okay, so what this will become? Now as x is approaching 0, what y is approaching? Just put the value of x 0 here. What will the value of y? 0, right? So as x is moving towards 0, y is also moving towards 0. So we can write pi upon 180 limit pi by 180 to limit x tends to, sorry, now this is y, right? This is y, not x anymore. Y tends to 0, sine y upon y. And how much this equal to? This is equal to how much? Yes, multiplied by how much? What's the value of limit x tends to 0 sine x upon x? 1, right? Huh? Have we done this or not? See, this problem we had done before also. See, this problem we have done this before, isn't it? Same thing I'm doing again. Same exact same problem. So this will be equal to pi by 180, not 1. All right. Okay. Yes, miscellaneous. How many of you solved exercise 11? Sorry, 13.2, right? 13.2, right? 13.2. Anybody is having doubt in 13.2? We can go through it. We can go through all the exercise problems one by one. Anybody is having doubt in any of the problem? Shreya? Hari? Shri Kruti? No doubt. Did you solve all the problems?
Examples are solved.
What? Can you please repeat? I'm sorry.
I have solved the example sums, sir.
Examples. Why? Okay. Okay. Let's find out. Find the derivative of sine x plus 1. If y is equal to sine x plus 1, find y dash. That means derivative of y with respect to x. Whew. Yes, sir. Please tell me. What's the answer? See, you can use first principle method. They have asked to use you first principle method. Okay, using first principle method. What is first principle method? So you have to find f dash of x. That will be limit h tends to 0, f of x plus h minus f of x. This is the first principle upon h, right? Isn't it? This is the first principle, no? We have studied in the beginning. Where is it? Derivatives. Yes. See, derivatives, right? This is what we have studied in derivatives as the limit of sum. Okay. See, this is what we have studied, no? Derivatives. This is the first principle. Okay, so solve it using first principle method. Find out the limit h tends to 0. Okay, limit h tends to 0. Now h1 upon h, let's write like this because we don't know the, this is not the part of function. Now function is sine. So f of x is sine x plus h, x plus 1. Now instead of, so f of x plus h, what you'll write? See, if you have f of x is equal to sine x, right? So f of x plus h, what you will write? Sine x plus h, right? So if how you write x plus h plus 1, this you'll write sine x plus h plus 1. That's how you'll write. Now write down sine x plus h. Sine x plus h plus 1. Is that okay? Minus sine h, right? So instead of just write sine x is x plus 1, isn't it? There is no h here. We have just added h in the function. Okay, so is this correct? First we have written the limits. Okay, now what we can write? See, this is sine a, this is sine a, and this is sine b. So what is sine a minus sine b? What is sine a minus sine b? Anyone? So this is 2 cos a plus b by 2 sine a minus b by 2. Correct? Yeah? Okay. So this will be limit h tends to 0. Now let's write down 1 upon h is already there. Now let's write down 2 cos a. What is a? X plus h plus 1 plus b. B is what? X plus 1 whole divided by 2 to sine a minus b. So x plus h plus 1 minus b. B is what? X plus 1. Isn't it? Divided by 2. Okay. This will become limit h tends to 0, 1 upon h, 2 times of cos. Now in the bracket, see, this is 2x plus 2 plus h, right? So 2x plus h plus 2 divided by 2. Here what is this? Sine x plus h plus 1 minus x minus 1. So this will be h by 2, right? You will open the bracket here. At this point, if you open the bracket, what you'll get? Minus x minus 1. So this x and 1 will, you can just remove and you have h by 2. All right? Yes or no? Okay. Now let's write it down again. So limit, this will become limit h tends to 0. Okay, 1 upon h. How we can, what we can write here? 2 cos okay, so we have, see, we have here sine h by 2. So this 2 can we take it here? So this is 2 by h here, right? So let's write down 2 by h, 2 is also a constant, cos 2x plus h plus 2 divided by 2 into sine h by 2. So can we write this as limit h tends to 0 cos 2x plus h plus 2 divided by 2, okay, multiplied by limit h tends to 0 sine h by 2 upon h by 2. Can we write like this? Okay, so this will become 1. This value will be 1, right? What will be this? Just substitute h is equal to 0. What you will get? If you substitute h is equal to 0, what you will get? Let's substitute h is equal to 0. So if you substitute h is equal to 0, you'll get cos 2x plus 0 plus 2 divided by 2 into 1. So this will become, now cos, you can take 2 common, x plus 1 divided by 2. This is all part of angle. So this will be cos x plus 1. So the derivative d upon dx of sine x plus 1 is equal to cos x plus 1. Now let's do it using algebraic method. Okay, so so y is given sine x plus 1, right? Let's replace x plus 1 with some function t. Okay, right? So dy upon dx. Okay, so let's replace it first. So y is equal to, this will become sine t. We can find dy upon dt directly, which will be equal to cos t, right? This will be equal to cos t, but we need to find dy upon dx, not dy upon dt, isn't it? So how we are going to do it? First, let's just replace t. Okay, so let's replace t is equal to x plus 1. So dy upon d of x plus 1, okay, is equal to cos x plus 1. Now see, check the denominator, d of x plus 1. That means derivative of x plus 1. So this is derivative of x plus derivative of a constant. So derivative of a constant we know is 0. So this will be dx only. So this you can write dy upon dx is equal to cos x plus 1, right? See, this is just simple derivative. Here this is derivative with respect to t, and we need to find derivative with respect to x. Okay, the meaning is that. So this is derivative with respect to t, and this is derivative with respect to x. See, we needed to find, this just represent the change. This one, this just represent the change. That means simple derivative. Okay, this just represent the change, how much it is changing, not with respect to any variable. Understood? This is the algebraic method. Okay, let's solve another problem. Solve this one, question number, let's say 5. Question number 5. What is this? Ax plus b. So all problems, question number 1, all problems in question number 1, that is, there are 4 problems that can be solved using first principle method, exactly using this method, these steps. Okay, now ax plus b upon cx plus d. How you'll find the derivative of this function? So this is y is equal to this. So find dy upon dx. See, just use quotient rule. Okay, we know this d. Just use quotient rule. What is quotient rule? If y is a function of f upon g, then y dash, which is dy upon dx, will be g into derivative of first function minus first function into derivative of second function divided by second function whole square. Write down. Find out. Let's find out the solution. Yes, tell me. Somebody please tell me the answer. Yes, you got the answer. Anyone please tell me the answer. See, y dash will be dy upon dx, which will be equal to first function, which is the let's write cx plus d and multiplied by derivative d upon dx of first function, that is ax plus b, minus you write ax plus b into derivative of second function d upon dx of second function. Which one is the second function? The denominator, cx plus d, whole divided by g square, that means cx plus d whole square. Okay, so this will be equal to cx plus d into derivative of ax. Ax derivative will be a, and b is constant, so derivative of b will be 0, minus ax plus b. Similarly, here we have c plus 0. Okay, derivative of cx will be c and derivative of d will be 0. So upon cx plus d whole square. So this will be equal to a times ac into x plus ad minus acx minus b into c. So these two will get cancelled out upon cx plus d whole square. Okay, so this will be ad minus bc. So dy upon dx will become ad minus bc upon cx plus d whole square. I think, yeah, cx plus d whole square. Okay, find out this. See, if you won't solve problems, I can't help you. You have to solve problems in order to understand. At least try in home. F of x is equal to x to the power of 100 upon 100 plus x to the power of 99 upon 99 up to x square by 2 plus 1. Oh, sorry, x into x plus 1. You have to find f of, no, I think you have to prove, okay, prove that. Okay, prove that f dash of 1 is equal to 100 times f dash of 0. Find out. See, f dash meaning is what? F dash, that means derivative of this function. So let's find out f dash. F dash of x will be equal to, now derivative, that means d upon dx of this function f of x, right? D upon dx of x to the power of 100 upon 100 plus d upon dx of x to the power of 99 upon 99 plus so on d upon dx of x square by 2 plus d upon dx of x plus d upon dx of 1. Okay, so this will be equal to 0. This will be equal to 1, right? So you can write f dash of x is equal to, this will be 100 x to the power of 99 upon 100 plus 99 into x to the power of 98 upon 99 plus next number will be 98 x to the power of 97 upon 98 and so on, plus this will be 2x upon 2 plus 1, right? Now this you can see, these numbers you can just cancel, right? So ultimate and plus 0, ultimately what you will get? F of x, f dash of x, f dash of x you will get x to the power of 99 plus x to the power of 98 plus x to the power of 97 plus so on up to x square plus x plus 1. How many numbers are there? 98, 99. So up to here, 99 numbers you have plus 1, that means 98, right? Now let's find out f dash of 1. F dash of 1, that means substitute x is equal to 1. So 1 to the power of 99 plus 1 to the power of 98 up to 1 square plus 1 plus 1. So this will be equal to 100. Okay. Now f dash of 0. So f dash of 0 is what? 0 to the power of 99 plus 0 to the power of 98 plus 0 square plus 0 plus 1. So this will be equal to 1. So clearly 100 times of 100 times of what? 100 times of f dash of 0 is equal to what? F dash of 1. Can we write like this? Hence proved. Okay, this was exercise 13.2, question number 5. Okay, this was question number 5 of exercise 13.2. See, please solve all the problems and ask me doubt tomorrow. Okay, tomorrow we can clear out any doubt if you have in derivatives. Otherwise, it's relatively easy chapter if you just follow the rules. Okay, so here we'll finish the derivatives. See, if you are solving problems, then only you will find out where you are exactly stuck. Okay, then only I can just clarify your doubt. Otherwise, without just keep solving problems is not going to help you. Okay, that is for sure. So please solve the exercise, full chapter, exercise 13.1 and 13.2 and miscellaneous exercise. Okay, so here we are finishing this chapter number 13. Which is the next chapter that you want me to do? 3D geometry? 3D
Okay,
geometry.
sir.
So how many chapters are remaining? 3D geometry, probability, statistics.
Statistics, sir.
What? Statistics. That's what. Probability and statistics. Is it combined chapter?
No, sir. No, sir.
Okay, let me check. Okay, it is not combined, right? These two are different chapter, right? Okay, so first we'll do 3D geometry. So for that we'll study few parts of vectors, because vectors and 3D geometry should be the name of chapter. I don't know why it is not. And then we'll study probability and statistics. See, there is another information that I can give you, but like derivative of determinant. So maybe you'll be studying that in next year 12th standard. So let's leave it here. Okay. So please go through all the problems and let me know if you have any doubt. So we'll end the class here today. Thank you.
Thank you, sir.
Thank you, sir.
See, if you have doubt, you can ask me now also. No one. Very good.